example 5 says that if the expression kx squared minus 2x plus 5 is always positive, where k is a constant, find the range of values of k. Well, in this analysis part that you see, they're thinking of what does that mean if something is always positive. So what they're saying is that this graph, k squared minus, kx squared minus 2x plus 5, notice that it has a certain feature that we've been talking about. It doesn't have any x-intercepts, right? We know that right off the bat. So this has 0 x-intercepts. Well, that means something very specific to us, doesn't it? Right? If it has 0 x-intercepts, we know that our discriminant can't be 0 or more, right? It has to be negative. So we know this implies that b squared minus 4ac is less than 0. We know that that is true. So what we need to do is use this as the scaffold for getting our answer. Okay, so now one thing I want to point out before you kind of move along is that let's say if this graph was negative always. Notice that when it's negative always, it still doesn't have any x-intercepts. So we follow this pattern the same way. So try also not to link the fact that positive means greater than 0 for the discriminant. And that, in fact, means the opposite. So anyway, as I'm going to go along and stop confusing you, we're going to follow this scaffold. So b squared. So if we look at b squared, b in this case is negative 2. We subtract away 4 times a, which is k, times our c, which is 5. And we know that that must be less than 0. So we've got 4 minus 20k is less than 0. I'm going to move the 20k over, and so I'm going to get 4 to be less than 20k. And therefore, k, if we divide by 20, has to be greater than 1/5, right? So that is how you have to do those problems. Just make sure that you figure out what about the problem, what am I reading, I can take somewhere else. I can say this is also true. And so if we're doing those things, we're going to be pretty successful. Just make sure it always goes back to the discriminant.